Here's another example, like what we did in class, graphing a system of inequalities. And we've got three inequalities. They're linear, and we're going to stick with linear for a little bit, where we're not going to have x squareds or sines or cosines or x cubes or anything like that. And we're looking at these inequalities. We want to know what's the reason where they're all true. And so one good first step is to graph the equalities. And one thing is that what we discovered in class is that we're going to be very interested in the intersections of these guys. So we're going to need to do some algebra and solve some systems. But one question that was asked, at least in second period, was, well, how do we know which intersections are actually going to be in the boundary of the region? And that's a little tricky from the start. So it's good to have some sketch, at least, of the equations. In other words, the lines that we're going to get here. And here's a hint on that. Well, let's first just convert these to equations. A really good way to sketch a line that people don't seem to know enough is if you're going to sketch like 2x plus y equals 6, then all we need to know is 2 points on that line. Well, two really good points to know anyway are probably the x and y intercepts. So sketch a line using intercepts. So for example, with 2x plus y equals 6, if y equals 0, that's the x-intercept. It's just cover up. 2x equals 6, x equals 3. Real easy. If x equals 0, that's the y-intercept. Oops, not 90. Let me just actually write that down. That's the x-intercept. Colon there. And if x equals 0, cover up, you get y equals 6. That's the y-intercept. And so you just connect those two dots and you've got an accurate version of the line. You do not ever have to plot more than 2 points on a line as long as you've got a straight edge. Just plot 2 points and then connect them with a straight line. Even if you're trying to plot it really carefully, just use a straight edge on graph paper and you're going to be good. So that's going to be one of the lines. The other lines are similar. X minus 3y equals 0. If I'm just going to copy this in, but just change the numbers. It'll be faster. If y equals 0, then x is going to be 0. Now this is a little tricky. Okay, that's the origin, and this is the one case where the plot the two intercepts method doesn't actually work. It's going through the origin, which is super crucial. You want to know that. But if I then put in x equals 0, I would just get the origin again. So I just have to plot any one other random point. So let's just put in like x equals 1 or something like that. Or even, just to make it really simple, I'd say y equals 1. Okay, y equals 1 gives x equals 3. Okay, and that's another random point. So the one place where the two-intercept method doesn't work is where it goes to the origin, where basically where this is 0. But you just plot the origin and then some other random point. Okay, and then the third one is going to be, that's where we can use the two-intercept method. If y equals 0, then x equals 1/2. And that's going to be the x-intercept. And if x equals 0, then y equals minus 2. There we go. And that's the y-intercept. Okay. So that would allow us to plot carefully all those three lines. And so let me go ahead and let the computer do that for me. Okay, that's not really happening. Okay. It's not happy about that. Oh, because it's a relation. Okay. Implicit. There we go. Okay. And okay, let's make that a little bit bigger. Let's have the view be like -8 to 8, -8 to 8. Okay. So there's one of our lines. 2x plus y equals 6. X minus 3y equals 0. Let me add that in. X minus 3y equals 0. Now we've got 2 lines. That's the one through the origin. And then the last one was 4x minus y equals 2. I'll add that in. So I'm not suggesting this is where you need to go to the computer. This is where you can still do this all by hand. It's really not bad, just using the data. So I think I put that in as number 1. That was silly. I need to add back in the 2x plus y equals 6. Okay, there we go. Okay, so there we should have 3 lines. There we go. Okay, so now those are 3 lines, and there's a bunch of different regions that we could be interested in depending on how those inequalities worked. Let's bring back the actual inequalities. Bring them down here. Okay, so 2x plus y less than or equal to 6. Now, the usual method of doing this is test points, and for these, the first and the third, we can just test the origin. 0 plus 0 is less than or equal to 6. Yes, that is a true fact. So that was this guy. And the origin is in the allowable set for that. So it's everything down and to the left of that. X minus 3y less than or equal to 0. That's where we can't choose the origin, but choose anything else. Let's choose like 1 comma 0. Is this point, remember this is this line. This guy's the one through the origin, that's this line. Is this point 1 comma 0, is that going to satisfy this? 1 less than or equal to 0. False. So that's not going to be in. Okay, so it's everything above that line. And everything down and to the left of this line. And 4x minus y greater than or equal to 2, we can use the origin there. Is it true that 0 minus 0 is greater than or equal to 2? No. So that means it's not the side with the origin, it's on this stuff on this side. Okay, so it's the triangle. So if they were going to ask us if it's bounded, the answer is going to be yes. And it's really crucial that it actually were these exact 3 inequalities to get the triangle. Any other reversal of these inequalities would have been one of these other different of these like 7 different regions. Okay, so it is that triangle, but then to really nail it down, we want to get these vertices. So here's the annoying thing: is that if you're really good at plotting these carefully, as I said, if you can plot the lines carefully, then you're probably pretty good. But you really have to plot them carefully, because one thing I'm going to be looking for is these vertices should be really quite accurate. Not to like the 1/10 of a millimeter, but they should actually be right in the right place. And so, but if you're using graph paper and you use the strategy that I suggested with the 2 intercepts, and you plot those carefully, you should nail them down, but we still need to label them and find them. And what I often suggest is try to rough out this picture first, and then really nail it down only after you really know the intersections, because that really helps to get a very, very precise picture. And in fact, once we know the intersections and we know it's a triangle, we don't actually need any of the rest of the picture. Kind of up to you exactly the order to do things, but the intersections are really important. So, for example, one of the intersections would be to take this system and take this system and just delete one of the equations. Notice we're not interested in solving the whole system. Let me go back up one more time, sorry. We could say, oh, we're just going to solve this system of 3 equations. We know how to do that. But that would be the place where all 3 intersect. That's not interesting to us. And it's clear from the picture there is no such thing. Usually 3 lines don't intersect at all. And there is no one intersection. We're interested in all the intersections of pairs. So that's a little tricky in terms of the logic. We're actually selecting 2 of the equations and solving that system. Solve it any way you want. I'll let the computer do it. 18/7 and 6/7. And so that's going to be, that was this line and this line. So here, this point is 18/7 comma 6/7. And it looks about right. 18/7 is between 2 and 3. 6/7 is just about less than 1. And so that we would label with 18/7, 6/7. So let me actually do that. Just to be honest, let's see. So 18/7, 6/7, and then I'm going to position it at like, let's see, 2 comma 1. Let's see if that works. It might kind of be bad. So you're going to want to label all 3 of those guys. Oh, that's way too big. Sorry about the font, but that label would be attached to this point. Let me fix it real quick. Labels. This guy. just make it smaller. I can't make it smaller than 12. Okay, never mind. Okay. So that's the label for this point. We want to label all the other two. Okay. So and then you'd shade in the region for the triangle. And what you get, I actually had the computer do it. It does it in kind of a weird style. It doesn't actually plot the lines. What you're going to get is this shaded region. And we want to have all these three vertices carefully delineated. And remember, that's going to be from solving this pair of equations and also solving these two together and solving the first and last together. And it's a lot of work, I admit, but you do need to do all of that to get a good precise answer.